Hey, what is going on everyone? I'm Wicked, welcome back to my Dart from Novice to Expert complete course. I hope you're having a great day. In this tutorial we're going to hop on the Flutterly train and move over to the next important station of our Dart language tour, and that is Dart control flow statements. So without further ado, let's get right into it. Beforehand though, I want to send a token of appreciation to everyone supporting me as official YouTube members, especially to Diana and Michael aka Aza on Discord. If you want to become a member, all you have to do is to click the join button right next to my channel and pick your desired membership. Having that said, let's continue with our tutorial. Now, in order to talk about control flow statements, we first need to see what I mean by saying the flow of an application. So, we learned from previous tutorials that whenever you run a Dart application, it will start its execution process inside the main function. Therefore, the flow starts right in here, and it will advance line by line to the next step. The best way to visualize this flow is to add a breakpoint right at the start of the main file and run the application in debug mode by hitting the F5 keyboard shortcut. You will be able to follow the flow of an application by simply watching this arrow right here. You can advance to the next step by clicking these buttons or by hitting F10, F11 or F12. The step in F11 shortcut will get you to absolutely each line of the execution flow, including functions and nested functions. Literally every line of code. If you'd like to skip the path inside functions, you can use the step over F10 shortcut to progress. And if you are already inside a function call and you want to exit, you can press the step out F12 shortcut. So, you saw the execution flow of our current basic application. But the thing is that this tutorial is named control flow statements, right? Therefore, there must be some statements that can modify, that can control the way the flow goes from one line to another. For example, if we use an if statement, then, depending on the value of the Boolean expression inside of it, one of the paths here will remain unexplored into the execution flow, right? Or, if we use a for loop, then the code inside the statement will be repeated in the flow of the application, so that instead of writing 5 print statements one after another, we can write only one and tell the flow to repeat it. Having this in mind, here are the statements that you can use in order to control the flow of a Dart application. Starting from the if and else statement, I'll tell you everything you need to know about each of the available control flow statements. Bear in mind that try, catch and throw statements, since they can raise exceptions and thus stop the flow of a program, are also control flow statements. Hence, we'll also discuss them inside this tutorial. First and foremost, let's talk a little bit about the if and else statements. Now, I know many of you already know mostly everything about if-else statements and their syntax. However, I need to remind you 4 important things about them. Firstly, and probably one of the most time-saving quick tips I could give you, is that instead of manually writing the if and else statement, just like this, you can use the already existing Dart snippets. As you can see, if we type in if, you have 2 snippets emerging as autocomplete options. The first one will generate the simple if statement, and the second one will generate the if plus else statements. Secondly, having what I said in mind, you can deduce that the else statement is optional, so you don't need to write an if-else combined statement. You can only write an if and do something only if the expression inside of it is true. Thirdly, I need to remind you from the tutorial on Dart built-in types that the expression inside of an if or else statement must always evaluate into a Boolean value. They can either be true or false. Nothing else is accepted as a condition inside of these statements. Last but not least, as we have already seen in the previous tutorial, the usual if and else statement can be written as a conditional expression. This time, take in mind that the else statement is also obligatory, so you can turn a long statement like this into something pretty neat, just like this. And I think this is pretty much everything you need to know about if and else statements in Dart. It's time to move over to what's probably the most popular statement you'll use when deciding to iterate or to loop through something in Dart, and that is the for loop. So in order to iterate through something, let's create a list of integers containing values from 1 to 5. Just as before, Dart comes with some really handy for loop snippets, so that instead of wasting a lot of time manually writing their syntaxes, you can simply use the default for snippet or the for in one. Now, the difference between these two approaches is that in the default one, you can also access the value of the index inside the iteration. In the case of the for in approach, the item variable is actually being assigned to each value of the collection from inside the iteration. Having this in mind, we can deduce that the default for loop approach is more robust and can be used with iterations inside of which you care about the iterating index. And you can even change the iteration index to increment in a different manner perhaps. If you just want to directly iterate through an iterable collection from start to finish and you don't care about the current iteration counter, you'd be better off using the for in form of iteration. And speaking about iterables, you know from the tutorial on Dart functions that every iterable class benefits from a quick for each method that can iterate through every item inside a collection really fast. While it can take an anonymous function as a parameter in order to have access to each item, if you just want to print the values, you can directly send the print function as a parameter by using its name. If this seems strange to you, make sure you revisit my tutorial on Dart functions as it's really important to understand these concepts. Alongside for loops, Dart also supports while and do-while loops, and it also comes packed with their useful snippets. Basically, the only difference between them is that the while loop evaluates the condition at first to check if it can still proceed looping. Do-while, on the other hand, evaluates the condition after each loop to see if the next loop can still be executed. So, the do-while will obligatorily do a loop at first no matter the condition is before it does the first condition check. From my experience, I have rarely used the do-while syntax. It's always a matter of condition tweaking to convert from a do-while to the simple while loop, so it's not worth the hassle to use both of them, at least in my perspective. Note that due to their syntax, while and do-while may cause infinite loops if the condition never changes to something that evaluates into false, so take that in mind. And since we're talking about this, you may ask yourselves, are there any ways on how we can directly interrupt the execution of a loop while being inside that loop? Let's take our previous for loop example. I want to exit the loop whenever I'll find a value of 3 inside the list. So what I could do is use an if statement, and if I find a value of 3, I could set the iterator value so that for the next iteration it will exit the loop. While this is completely fine, you have to agree with me, it looks absolutely terrible. There is a much cleaner way on how you can interrupt the execution of a loop, and that is by using the break statement. Wherever you want to cut the loop execution, just drop in a break statement, just like this. And now, as you can see, it works the same as before. But not only that, but it also looks seamless. Break statements can be used inside any for, while, and do-while loops in order to prematurely stop them from running. Having talked about this, you may ask, well, if we can use break to completely stop the loop, is there any softer way on how we can skip only one iteration and move to the next one inside the loop? For example, is there any way on how we can skip printing the value of 1 from our list's for loop? Yes, it is. We can write if item equals 1, then continue. The continue statement will end up the current iteration and move to the next one inside the loop. Of course, you could have written if item is not 1, then print the values, which would seem a more logical thing to do, but for learning purposes, I showed you how you can do this by using the continue control flow statement. There is even a much cleaner way to do it, by using some list collection functions like where and for each to filter the items we want to print, then print them as we have previously seen. Now, you must agree with me, this looks better than using any for iterations, and this is the beauty of Dart. Everything can be written in such a minimalist manner. Now, having all this said, it's time to move over to a really interesting and important control flow statement, the switch case statement. At first, you should know that the switch case statement was designed to be kinda limited from a coding perspective. And as much as you think this is a bad idea, limiting stuff to work only on certain specific cases brings more stability into the game. Again, there is an implicit Dart snippet for it, so make sure you use it every time you'd want to create a switch statement. So, you should think of a switch case statement as being more like a stripped down version of an if-else statement. Say we have a switch case written like this. This, as hard as it may seem to believe, is equivalent to writing this if-else statement. However, that's pretty much everything you can do with a switch case. Use it as an if-else statement, comparing a default single input value to a set of multiple other values. The limitations continue even further, since switch statements in Dart can compare only integers, strings, or compile time constants using the == operator. As we learned in the previous tutorial, in Dart, the only variables that are equal by default are those pointing to the same reference object in the memory, and variables pointing to the same objects in memory must always contain compile time constant objects. Remember, integer and string objects hold constant values, so it's absolutely facile for the switch statement to compare their values by using the == operator, since this operator will actually call the identical method on the values, making sure they point to the same constant object in memory. Another condition is that the class from inside the object you want to compare must not override the == operator, so that Dart makes sure you won't be able to alter the comparing process. The difference between identical and == operator was covered in the previous tutorial, so I invite you to watch that. It will definitely make more sense. Now, even though switch case statements only work with integer, string, and compile time constants, 99% of the time you'll find them being used with another type we haven't discussed yet, because I wanted to wait in order to introduce it in this specific context. I'm talking about enumerated types, or enums as everyone calls them. There's not much to say about enums. They look like this. You can declare them by using the enum keyword. What an enum basically is a special class used to represent a fixed number of constant values. So, for example, in my case, I have a weather conditions enum containing all types of constant conditions the weather can have, like sunny, cloudy, foggy, rainy, etc. They're not going to change. Most of the time, we'll use enums containing constant values just like this. And why do we do this? Well, because when comparing two objects, especially of type string, it's so easy to mistype a letter of one of the strings, and your program will go haywire really fast. So, to prevent this from happening, we use enums to encapsulate the specific value into a class and access it directly like it was a static field, just like this. Now all we need is to create a variable holding one of these class values. Note that the enum class cannot be instantiated, it only exists through all of its possible values inside of it. Coming back to our switch case statement, you can see it became really neat and organized. It isn't prone to string errors anymore. So let's talk a little bit more about these cases. These are called case clauses, and they can be either non-empty as we have them here and empty as we'll see in the following minutes. But first, let's focus on these non-empty fields. As you can see, by default, non-empty case clauses require a break, continue, throw, or return statement at the end, since whenever Dart finds two equal values, it's time for it to exit the switch statement. It can either do it by exiting it directly via a break, throw, or return statement, or by passing this job to another case clause by using the continue statement and a label, just like this. Using a continue statement may be used when you want to do something in response to two values. For example, in our case, in case it's drizzling outside, I would like to print both that it's drizzling and raining by using the continue statement just like this. On the other hand, in case of empty cases, you don't need any of these break, return, throw, or continue statements. But take in mind that if you have something like this, it will act just like before as a form of fall through. This time, for both when it's drizzling or raining, it will only print that it's raining, since it will fall from the condition that drizzly to condition that rainy, and it will exit the condition there from the break statement. Also, you can notice that there is a default case at the end, denoting the flow our app will take if there have not been found any cases for this input right here. However, in the case of an enum, you don't have to mention it since you can't have any other values as an input here. And at the same time, Dart will show you a warning if you won't write cases for all of your enums fields. And I think this was pretty much everything you need to know and learn about switch case statements and enums. Time to move on to the assert statement. The assert statement is one of the easiest statements to understand. It is used to disrupt the normal flow of a running app if the Boolean condition inside of it is false. So, for example, you might want to stop the program if this list is empty when it reaches the assert statement. So, what you want for the app to keep running past this point is to have this list variable not containing an empty list. Therefore, we'll write assert and the condition will be list.isNotEmpty. And we can also pass a second argument containing the message that will be displayed if the condition will be false. Now, a really important characteristic of an assert statement is that they are only present in the code when running it in debug mode. When running it into production mode without debugging, all asserts inside your code will be removed, and the program will run completely fine even though the condition will be evaluated to false. Therefore, asserts are mainly a tool that can aid the development workflow a little bit more by double-checking some important conditions. And having this said, we have only one more topic to cover before we end up this tutorial, and that is exceptions, especially the throw, catch, and finally control flow statements. Exceptions, such a beautiful and dangerous topic to be discussed. So, you must be pretty much aware that there are some places in your Dart code when something unexpected can happen, something that can cause your app to terminate. If something bad happens, an exception is thrown. Now, the dangerous thing about exceptions is that when they get thrown, if they aren't caught somewhere along the free falling, then the program gets terminated. In short, it crashes. And if your app crashes, users will be mad. And if users are mad, they'll give you bad ratings. And the chain of horrendous things will continue. The road, starting from when an exception is thrown to when your reputation as an app developer begins to drop, is really short, so you'd better catch those exceptions until it's too late. Think of an exception inside an app like throwing a ball from the 20th floor of a building. When the ball touches the ground, the game will be over, and this literally happens in a matter of milliseconds inside the program. So, what you should do is to have some catch statements along the way that can literally be more like some nets catching the ball from falling at a lower level. When an exception is caught, the program won't crash anymore, and you even have some ability to fix the problem by using the finally statement. Finally is more like an ultimate step on how you can fix your unexpected error. So let's see everything we learned into practice in the following minutes. Say for example we have a variable called 0 that must not contain anything apart from the value of 0. When it's going to have a value bigger than 0, we'll throw an exception. When it's going to have a value less than 0, we'll throw another exception. Now, in Dart, as expected, exceptions are, well, objects. Objects instantiated from the exception class, which is actually a built-in type. Similar to exceptions, Dart also has an error type, which pretty much acts the same as exceptions. A production quality code will always throw types or classes that implement either this error or these exception classes. As you can see inside the error class, for example, Dart devs have already created some errors that will be thrown in some dangerous situations. Similar to how they implemented their own specific exceptions and errors, this is how we can actually implement our own. So all we need to do is to create two exceptions. I will call them positive value and negative value. Both classes will implement the exception class, and don't worry if you don't know what the implement keyword does for now. We'll learn everything about classes in the following 2 tutorials. As you can see, every exception must have a message, so we're going to set a final field like that and set it into the constructor of both classes. Now we have an utilitary from inside the math library that can generate 2 numbers between a range of numbers. In our case, this line of code will generate an integer number between -1 and 1, so a random value between -1, 0 and 1. We want to detect if our variable got an unexpected value, so we're going to surround our next code in a try-catch block, as you can see, by using the already baked-in Dart snippet. Inside of this, we'll test the possible problems that may arise, and those are whether our 0 variable is less or greater than 0. In either of these cases, we'll throw the corresponding exception. So, this is the moment where the ball starts dropping from the 20th floor, so we need to catch it before it's too late. We can do that in 2 ways. We either use the on keyword followed by the exact specific type of exception, and if it matches, it will catch it and enter its scope, just like we did with the negative exception. However, know that in this case, if you don't treat any possible exceptions that may arise, they won't match any of your options here, and it will eventually end up not caught, hence crashing the program. And this is why it's recommended that we use the catch statement that will literally catch all types of thrown exceptions. Inside of the catch scope, you can check whether the type of the caught expression is of one of our expression types, and if it is, proceed like we did above by printing a specific message. And as a final step, after we catch the exception, we can use the finally statement to set the 0 variable to hold the correct 0 value. If we run the program right now, we'll see which ones of the expressions will get thrown and caught, and how the flow of the application will progress during all these steps. One thing left to be mentioned is that after catching an expression, you can also rethrow it in order to be catched later on with another catch statement. This is like playing with fire and rethrowing the ball after you caught it on a lower level so that another person with a net will catch it from a more inferior level. I hope you understood how exceptions work inside Dart and how the try, catch, and final statements can control the execution flow of an app. Having that said, it is finally time to end this tutorial on Dart control flow statements. I hope you understood them in great detail. In the next tutorial, as I previously said, we'll move over to the next station of this Dart language tour, in which we'll start discussing everything we need to know about classes in Dart. As always, if you like this tutorial, don't forget to smash that like button, subscribe to my channel, and share the video with all of your friends and colleagues in pursuit of top tier development. Until next time, as always, take care, Wicked is out, bye bye.